Welcome to a lesson with Dr. Powell. Let's look at identities for cosine of 2 theta and sine of 2 theta. We'll think of cosine of 2 theta as being cosine of theta plus theta. Then, if we use the identity for cosine theta plus theta, introduced in another video, which is we're thinking of this as two different angles, but they're the same in this case. So we have cosine of theta times cosine of theta, which is just cosine squared, minus, and then sine of theta times sine of theta. So we get sine squared theta. Again, let's kind of review where this came from and what it is really quickly. So this comes from the identity cosine of theta plus phi is equal to cosine of theta cosine of phi minus sine of theta sine of phi. But then phi is equal to theta, hence we get this right here. Okay, so then let's keep going right here and see what we can do. Let's use a Pythagorean identity now, which is cosine squared theta plus sine squared theta is equal to 1. And let's replace sine squared theta with something with cosine squared theta. So let's solve this over. So we have 1 minus cosine squared theta is equal to sine squared theta. And we can use this right here in place of sine squared. And so we end up getting cosine squared theta. Let's see, minus, and then we'll distribute the minus to the 1 and that. So minus 1, but then distributed to that negative become plus. So plus cosine squared theta. So we end up getting 2 cosine squared theta minus 1. So cosine of 2 theta can be either thought of as cosine squared minus sine squared or 2 cosine squared minus 1. In fact, even just from this identity right here, with cosine 2 theta being equal to this, we could solve for cosine squared if we wanted to, and even get cosine squared theta is equal to, if you add 1 over and then divide by 2, we get another identity, which is often useful for changing a square of cosine into something that doesn't have a square. Okay, now let's take a look at sine 2 theta. Okay, so we're going to use the identity sine of theta plus phi is equal to sine of theta cosine of phi, and then you just switch places with the plus sine of phi cosine of theta. All right, so we get that, and if we just replace phi with theta, then we'd have sine of 2 theta would be equal to sine theta times cosine theta plus sine theta times cosine theta. In other words, it would be 2 sine theta cosine theta. This is a very nice identity to use. Very handy. Thanks for watching.